Let it snow, let it snow, let it snow.
It's December and I want it to snow on my computer screen in a window kind of like this. So every day until the 24th I'm going to improve on my program. This is actually the snow created by my program and get it working perfectly. Right now I have a problem. You see, the snowflakes are not moving at the same speed all the time. It looks like they speed up and slow down a bit. And yesterday I found out that's because my frame rate varies. Sometimes it's 59, then it's 63, 59, and 56, 67, and so on. So I have to adjust the speed when the frame rate varies. And today I'm going to look into that. And that requires math. Let thee be warned. Let's say I have a snowflake. It falls gently to the ground, and in 1 second I want it to drop or fall 60 pixels. That's the same as 60 pixels per second. If I have 60 frames per second, that's the same as 1 pixel per frame. So this would be pretty easy if I ran exactly 60 FPS and my speed would be 1, then I would add 1 for every single frame. But what if I run at 50 FPS? How many pixels per frame would I have to move in order to still move at 60 pixels per second? That's the challenge. Let's try to look at it a bit differently. How did we get this 1 pixel per frame? It seems kind of obvious, but let's just do the calculation. We have here 60 pixels per second, that would be our speed. We have 60 FPS, that would be not our time frames per second, we would actually like the how many seconds for a frame. So that would be 1 second divided by 60 frames. That would be, say, 1 divided by 60, 0.1666 and so on seconds. That would be our time. And our time multiplied by our speed, that should be our distance, the number of pixels we should move. And let's just say we have the time multiplied by 60, the speed is 1. Yeah. But let's use it. Let's say we have 1 over 50 for the 50 frames. That would be 1 divided by 50, 0.02, and then we say time multiplied by speed, 0.02 multiplied by 60. That is 1.2 pixel. I should write it right here. This would be our answer. 1.2 pixel per frame. So if I could get the time for each frame, then I could multiply that by the speed and get the distance I have to move the pixel in this frame. So the question is, how do I get this time between frames? Well, I could ask for the time right now. That would be date.now. That gives me the number of milliseconds since the 1st of January 1970. And if I remembered, say last would be date.now. That's the last time I asked, and I'm asking again just now, date.now. Then I can ask what's the difference? Now minus last. It took me 7,852 milliseconds. I could divide that by 1000. So, oops, I have to like this. So 7.8 seconds went by since the last time I asked. So if I could somehow get this move function, ask what time is it now, what time was it last time I asked how, and what is the difference. The first part is fairly simple. I could say let now be equal to date.now. And I could divide it by 1000 immediately to get the number of seconds rather than milliseconds. And then I could say the difference. I'm calling the difference delta. That would be the same as now minus last time we asked. The problem is, if I run this, there is no last time. So how do I handle that? Oh yeah, yes, I need to remember the last time. And actually that is every time I call move, I could then at the very end here say, oh yeah, just by the way, remember last time is the same as now. And I need to remember that outside the function. Let last be, yeah, just. So now I might have something. Let's just console log the delta. To see what happens. It's number 0.012. That looks kind of like almost 50, 60 frame rates here. So that's the number of seconds between each frame. I'm going to stop console logging them. Then I'm just going to multiply the speed with the delta, as I saw here. It's time multiplied by speed, time multiplied by speed. That should give me nothing at all. Let's look at the Y position. They are a bunch of nands, not a number. Why is that? Ah yes, the very first time we get it, last does not exist. So we can do like this, say last or 0. That means if last is undefined, then we get 0, and then it's like no time has passed us at all. Let's see how this goes. Oh yeah. But all of them are now extremely slow. And that's of course because the max speed is 10 pixels per second. Maybe I should set the max speed to 100 pixels per second. And the minimum speed to 10 pixels per second. How would that look? Oh, that looks beautiful. It looks very, very smooth now. Let's just, I'm pretty happy with this. I'm going to commit immediately. We'll call it fixed variant frame rate. Let's just take a look at full screen. How it looks. Oh, there is a problem with the responsiveness when I change the size of the screen. Well, I'll look into that tomorrow. See you then.
Let it snow.